those of you just joining us, we were talking about ways to simplify our expressions. And so we said we had 3 different ways. We want to convert into identities, change everything to cosine and sine, and then use algebra like getting common denominators and multiplying reciprocals, different things that we know how to do. It's just easier with numbers instead of words, right? So here is our first one. We're going to start off really, really easy. Totally got this. So I want you to simplify the cotangent of pi over 2 minus x times by secant x all over secant squared x. Bless you. All right. So first thing, so we can change this cotangent of pi over 2 minus x into tangent, right? That's going to be our first step. So I have the tangent of x times by the secant of x divided by the secant squared of x. So that wasn't bad, right? Now, what do you notice that right now, before we do anything else, you can cancel top and bottom? One of the secants we can get rid of. We can get rid of this one, right, and cancel it with one of them down here. So now I have the tangent of x divided by the secant of x. Okay, well, I don't have any more identities I can switch it out for, so now let's change it all to sine and cosine, right? Tangent is sine x over cosine x divided by secant, which is 1 over the cosine of x. Everybody's okay there? Okay, so now we have a fraction divided by a fraction, which means we have to multiply by its reciprocal. So we're going to take this bottom one and flip it over, which is cosine x over 1. Get rid of that. So now what do you see cancels? The cosines cancel. And what are we left with? Sine x. Nope, your x is all gone. It's just sine x. So this whole mess up here equals sine x. That clicked? Okay. So I think if I continue to say, what can we switch out here? Let's change it to sine and cosine, and let's work through it that way. I think if that might work for us. All right, we all doing good? Let's try another one.
It also makes more sense, like, simplifying, I think, other than, like, in the very beginning of the worksheet when we were, like, I don't know, it gave us the given and...
Right, so it was a little bit different. So simplifying gets better. So hopefully we're going to get there. You guys are going to do great. There's no question in my mind. So let's do example number 2. Let's try another one. Again, we're going to simplify it, and let's simplify cosecant squared x plus secant squared x minus, and in parentheses, let's put cotangent squared x plus tangent squared x. Sorry, I can't squeeze her in there. All right, I wrote too big. All right, so we have 4 terms long polynomial we got going on here. We want to simplify this. All right? So the first thing is in our Pythagorean identities, we have something that means cosecant, don't we? What is it? In our cosecant squared, in our Pythagorean identities, we have something. No, try again. What do we have in our Pythagorean identities? Yeah, so we can change this out for cotangent squared x plus 1, right? That equals that? Okay, plus. Do we have something in our Pythagorean identities that means secant squared? 1 plus tangent squared x. All right, now if I have a negative in front of a parenthesis, what do you think I got to do there? Distribute. So I'm going to subtract or have negative cotangent squared x minus, get that out of my way, hopefully. Get out of the way, maybe. Oh, there we go. Minus tangent squared x. Yeah, so you'll notice our cotangents cancel. Our tangents cancel. What do we have left? 2. Exactly. That whole thing is 2. I know it's crazy and it looks weird, but. Alright, so let's try one a little tougher. Okay, we can do it. Here's example number 3. Let's go with cosine x times by cotangent x plus tangent x. Alright, so looking at this, we can't use Pythagorean identities because nothing's squared, right? So we can't do that. So let's start by getting rid of the parentheses. We're going to have to get rid of them anyway, so shall we distribute? Okay. So cosine times cotangent is cosine cotangent plus cosine times tangent is cosine tangent. All right? Now, if we can't use any of our Pythagorean identities or anything, we go to switching everything to sine and cosine, right? So we have cosine, that stays. Cotangent is cosine over sine, exactly. Plus, here we have cosine times by sine over cosine. All right. What do you notice? Can we cancel anything here? Nope. So this is cosine squared x over sine x. Everybody agree? Plus, what do you notice over there? Those cancel. They sure do when we have sine x. All right, we're almost there. They can cancel. There's a plus in the middle. So if I have a fraction added to something else, what do I have to get in order to put them together? A common denominator, which means I'm multiplying this one by what? We're going to multiply this one by sine x. Exactly. So on the top, I'm going to have cosine squared x plus sine squared x all over sine x. We're all good with that? Yep. Now, what is that wonderful numerator equal to? 1. It is. It's equal to 1. It's our top Pythagorean identity. So this equals 1. So we have 1 over sine x. Maybe. What is 1 over sine x? Cosecant x. So this whole mess came down to cosecant x. Again, if you take it step by step, though, it isn't that bad, right? Questions on this one? Anything we want to go back, talk about, revisit? Go ahead. Uh-huh. There's always this over here, and this one? This one and this one canceled, right? This should have an X on it. It didn't. That should be there, yeah. Yeah, it's just, I get lazy once in a while, I'm sorry. So yeah, the cosine X's cancel because they all go together. So we're just left with sine X. Anybody else? Anything else? Are we doing okay? We're doing all right? Okay. We're doing, all right, let's try one last example then, and then I'll tell you how many problems we're going to do today. Example number 4. Well, I don't know how much space you have. You better turn the page. You better. All right, so let's look at one like this. Go with tangent x over secant squared x plus tangent x over cosecant squared x. All right. In this one, we can change them, but what's that going to get you? If you change secant squared into 1 plus tangent squared, but it doesn't because there's a plus in the middle. You can't cross those out or you can't cancel them, right? No, if I change this, and I'm going to write it right here, to 1 plus tangent squared x, that can't cancel with that because there's a plus in the middle, correct? So this is the perfect example of where it's going to be easiest if we change everything to sine and cosine, exactly. So our top fraction at the top numerator, tangent, is equal to sine over cosine. The bottom, secant squared x, 1 over cosine squared x. All right, so I just want to work with this first one real quick. To simplify this, if I have a fraction over a fraction, that means I've got to multiply by its reciprocal. So I'm going to take this bad boy, flip it over. So I have cosine squared x over 1. Gets rid of that. And then what cancels? Yeah, so I can get rid of this cosine with one of the cosine here. So what do I actually have for my very first term? Yes, sine x cosine x. Plus, now we're going to go do the other one. Okay, so again, tangent changes into sine x over cosine x over, what is this one? 1 over sine squared. Very good. And again, if I have a fraction divided by a fraction, I want to multiply by its reciprocal. So I'm going to bring that up here and say I have sine squared x over 1. Sine cubed x. Yep. Awesome. Everybody still good? Okay. So I'm just going to move this up a little bit so everybody in the back can see. So at this point, we have a term and we have one with a fraction in it. Common denominator, exactly. Which means I got to multiply the first one by what? Yeah, I got to times this one by cosine x. So I'm going to have sine x cosine squared x plus sine cubed x all over cosine x. We're still good? Okay. Now I want to talk about the numerator. In that numerator, what is in common in both terms? The sign, right? So I can undistribute a sign out of both of those. So on this top, I'm going to take a sign out. So I'm going to undistribute sine x. That's going to leave me with cosine squared x plus sine squared x. So this right here will equal 1, right? That cancels in 1. So all I have left now is sine x over cosine x. And what is sine x over cosine x? It is tangent. So, I know it sounds like a lot of steps, but were any of those steps hard? No, it wasn't. It's, again, thinking about your algebra. You'll be amazed by the time we finish this chapter and you're working with words. When we get back to where it's numbers and you go to do your algebra, you're like, oh, this is like so easy now. Okay? I will. All right. So I think today let's do no. Let's go 23. No, it's not. 1, 2, 3, 4, 5, 6. Let's go to 33. We'll go 23 to 33 odd. Okay? But again, I want everybody trying all of them because each one's a little bit different. If you get a roadblock, that's fine. Go on to the next one and we can go back. Okay? All right, try them all. So again, we're doing 23 through 31 odd. Or 33 odd. What? Yes. Please just add it on to last night's. We'll put them all together.